Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, we're going to discuss the roots of complex numbers. So let's start by writing down a complex number. So let r times cosine theta plus I sine theta be a complex number. So this complex number is written in what's called polar or trig form. Theta is called the argument, and r is called the modulus. And then we're going to let n be a positive integer. Then our complex number, so our complex number has exactly n distinct roots given by, give you the formula now, given by, and I'm going to write the formula using, well, I guess I'll write it using this notation here first. So it's the nth root of the modulus times, let's use alpha, cosine of alpha plus I sine alpha. And what is alpha? So alpha here is going to be theta plus 2k pi divided by n, where k runs from 0 to n minus 1. Okay, from 0 to n minus 1. And here, theta is in radians. So here, theta is in radians. If theta is in degrees, the formula is very simple, very similar rather, or alpha equals theta plus, you simply replace the 2 pi with 360 degrees. So 360 degrees times k over n. And everything else is the same, so I'll write it anyways, where k runs from 0 to n minus 1. And in this case, theta would be in degrees. So let's just go ahead and do an example right away. So you see how to use this formula. I don't want to scroll down too much because I want to make sure you can see the formula on the screen. Okay, so let's go ahead and do an example. So example, and let's maybe just start off simple. We'll find the square roots of 4i. So find the two square roots, I'll just say the square roots, there's two of them, square roots of 4i. So you'll notice that in this formula up here, the complex number was written in polar form, so a good first step would be to do that, would be to write 4i in polar form, which is also called trig form. So solution, so there's a couple different ways to write this in polar form. I think maybe the easiest way is to draw a picture. So 4i is here on the complex plane, and r is the modulus. So r is this distance here. So r is 4. So 4i is equal to 4, that's your r, parentheses, cosine theta, except what's theta here, right? Theta here is pi over 2 based off the picture, plus I sine pi over 2. Just don't need an extra parenthesis there. So whenever it's a quadrantal angle like this for your theta, it's very easy, like 4i, 2i, 3, things that lie on either the x-axis or y-axis. Any complex number that lies on an axis is very easy to write in polar form, because you can just draw a picture and you'll get the argument right away. For example, maybe it's over here. In this case, the argument is pi. Maybe it's over here. In this case, the argument is 3 pi over 2. Maybe it's over here. In this case, the argument is 0. So very easy when the complex number lies on one of these axes. So that's the polar form, okay? That's the polar form. So now we just have to use the formula. So all we're doing here is using the formula. So here's our formula. So we need the nth root of r. So n here is 2 because we're looking for square roots. So the square root of r is 4, is 2, okay, is 2. And so now we just need to figure out alpha. So alpha is equal to theta plus 2k pi. So theta here is pi over 2. That's our theta. It'll be pi over 2 plus 2k pi over n. And again, n here is 2. It's a 2 there. Hope you can see that. 2k pi. So let's just find the different values now. So let's see. When k is, well, k runs from 0 to n minus 1. So k is either 0 or 1, right? Because n is 2. So k is 0 and 1. So when k is 0, alpha equals, well, that's going to go away. So we'll just get pi over 2 over 2, which is really pi over 2 times 1/2, which is really pi over 4. And when k is equal to 1, we get alpha equals, would be pi over 2 plus, k is 1, so you just get 2 pi, and all of that is divided by 2. So this is pi over 2, and we're adding 2 pi to it. So think of 2 pi as a number over 2. One way to do that would be 4 pi over 2, and that's over 2. Going a little fast here with the adding of the fractions. Pi over 2 plus 4 pi over 2 is 5 pi over 2. And all of that's over 2. 5 pi over 2 divided by 2 is the same thing as 5 pi over 2 times 1/2. That's 5 pi over 4. So those are our two angles, pi over 4 and 5 pi over 4. And again, the formula, I'll write it down for you so you have it, is the nth root of r cosine alpha plus I sine alpha. That's the formula for the roots, where alpha is given by this formula here, which we just used, right? We use the formula. So now all we do is plug in the different values of alpha. So one of the square roots would be, well, what was this here? This quantity here we said was 2. We did that here. There's an invisible 2 here, right here. R is 4, so this is 2. Cosine of pi over 4 plus I sine of pi over 4. That would be one of the roots. You could work this out, so this would be 2 square root of 2 over 2, plus I square root of 2 over 2. Distribute the 2 and you simply get square root of 2 plus I square root of 2. The 2's cancel. So that's one of the roots. The other root we would get by plugging in 5 pi over 4. So 2 cosines, you see these problems take a while. This is actually one that's pretty simple, plus I sine 5 pi over 4. It's a pretty lengthy process. It's not hard. It just takes time. 5 pi over 4, where is that? It's down over here, right? Because we can think of pi as 4 pi over 4. So if you go a distance of pi over 4 more than that, you're going to be down here in quadrant 3. And here, both cosine and sine are negative because cosine is the x-coordinate on the unit circle, and x is negative here. Sine is the y-coordinate on the unit circle, and y is negative there. So those are both going to be negative root 2 over 2. So this is going to be 2 negative root 2 over 2 plus I negative root 2 over 2. And then you distribute the 2 here, okay? And the 2's will cancel. You'll get negative square root of 2 minus I square root of 2. So these would be the square roots. Both of these are the square roots of the pure imaginary number 4i. That's what these are. So we found the square roots of 4i. So it does take some work. And again, basically step 1 is you write it in trig form like this. I picked this one on purpose so it wouldn't take us a very long time. So pretty easy to do, just from a picture. Then you identify n, its square root, so it's 2. If it's cube roots, it's 3. If it's 4 roots, fourth roots, it's 4, etc. You take that root of your modulus, that gives you 2, and then you work out alpha. Okay, just use this formula here if you're in radians. And then n was 2, so 2 minus 1 is 1. So we only get 0 and 1. If n was 4, we would do 0, 1, 2, 3, etc. So you go up to 1 left. So if n is 6, you have to plug in 0, 1, 2, 3, 4, 5. And it's 10, which hopefully never happens, you plug in the numbers 0 through 9 and you get 10 different 10th roots. Thanks for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.